Section 11.2, Arithmetic Sequences. In this section, we'll find the common difference of an arithmetic sequence. We'll write the first n terms of an arithmetic sequence, and we'll use both recursive formulas and explicit formulas to describe an arithmetic sequence. And just in case you're wondering, this word, when it's used as an adjective, it's pronounced arithmetic. I know we're used to looking at that word and calling it arithmetic, but that would be the noun. So when it's used as an adjective, it's pronounced arithmetic. The value of a car depreciates $4,000 each year. The car was initially worth $26,000. Write the value of the car for the first 5 years of ownership. Okay, so in year 1, it was worth $26,000. In year 2, it would be worth $4,000 less. In year 3, $4,000 less from that. And again, $4,000 less and $4,000 less. All right, so you can think of this as the terms of a sequence. Our first term, our second term, our third term, our fourth term, and our fifth term. And we can write an example or a model for that. Let's do it recursively, and then we can also do it explicitly. So the value starts, a sub 1 is 26,000. And then how is the next term related to the one that came before it? Well, to get the next term, you take the one that came before it and subtract $4,000. So this would be an example of defining that sequence recursively. That sequence is an example of an arithmetic sequence. Why? An arithmetic sequence has a property that the difference between any two consecutive terms is always constant. And the difference is called, appropriately enough, the constant difference. And we usually use the variable d to represent the constant difference. And all arithmetic sequences have this form. So a sub n is going to be equal to the first term plus a multiple of the common difference. So this would be an explicit formula for the nth term of an arithmetic sequence. Let's practice determining if a sequence is arithmetic, and if so, finding the common difference. So is this sequence arithmetic? If so, find the difference and write an explicit formula for it. So let's check. Between 3 and 6, we would be adding 3. Between 6 and 9, would be adding 3. Between 9 and 12, we're adding 3. So yes, this is arithmetic, and the common difference is 3. So let's go ahead and we'll use this formula for the nth term. So the nth term would be equal to the first term plus n minus 1 times the common difference, which is 3. And let's go ahead and fill in what that first term is. The first term is 3. So this would be an explicit formula for that sequence. Let's just give it a try. What would it say a sub 4 is equal to? It would say a sub 4 is equal to 3 plus 4 minus 1, 3 times 3. In other words, 3 plus 9 are 12, and we can see that, yeah, that's the fourth term of the sequence. Is this sequence arithmetic? If so, find the common difference and write an explicit formula. Between these two, we add 2. But between these two, we add 4. So we're not adding the same thing each time, so this is not arithmetic. Because the feature of an arithmetic sequence is the difference between any two terms is always constant, always the same. Here, you try this one. Is this sequence arithmetic? If so, find the common difference. All right, let's check your work. So between these two, we add 4. Between these two, we're always adding 4. So the answer to that was yes. You weren't asked to, but let's go ahead and practice writing an explicit formula for the sequence. Remember, a sub n is equal to the first term plus n minus 1 common differences. So we could write this sequence as a sub n is equal to the first term plus n minus 1 times the common difference, which is 4. So arithmetic sequences can be defined explicitly or recursively, just depending on which you want to do. So this is an explicit definition of that sequence. If I wanted to define it recursively, remember I would have to say what the first term is. So a sub 1 is equal to 5. And then I would have to say, how do I get the next one in terms of the one that came before it? I would take the one that came before it and add 4. So this would be a recursive definition of that sequence. Common differences can also be negative. So for example, what do I add to 12 to get 6? Negative 6. What do I add to 6 to get 0? Negative 6. So you can see that this arithmetic sequence has a common difference of negative 6. Finding an explicit formula for an arithmetic sequence given two terms in the sequence. So in an arithmetic sequence, the first term is 8 and the fourth term is 14. Find an explicit formula for the sequence. So the first term is 8. The second term we don't know. The third term we don't know. But the fourth term is 14. And what we like to do is we would like to find an explicit formula for this sequence. So we know that the nth term is equal to the first term plus n minus 1 times the common difference. All right. And so we're going to use this information in this formula and see if we can come up with an explicit formula. In other words, what we need to do is we need to solve for d. All right. So what do we know? This is the fourth term, and this is the first term. So when n is 4, a sub n, 14, is equal to a sub 1, the first term, plus 4 minus 1, 3 times d. Or in other words, solving this simple equation, we can find out that the common difference is 2. Let's just give that a try. Add 2, add 2, add 2. Yes, that works. So the explicit formula would be a sub n is equal to the first term plus n minus 1 times 2. And again, in general, the formula for the nth term is a sub n is equal to a sub 1 plus n minus 1 times d. So this is an important formula to be able to have ready to use. You can also use the formula for the nth term and solve for any of the variables. So we just used it to solve for d. Here, in this time, we'll use it to solve for n. Find the number of terms in this finite arithmetic sequence. It starts with 8 and goes to negative 41, but we don't know how many terms there are. So we're going to use this formula, but this time we're going to solve for n. So a sub n, the nth term is negative 41. We don't know what n is, but we know the last term is 41. It's equal to the first term plus n minus 1. And we can see the common difference in this problem is negative 7. So all we have to do is solve this equation for n. Why don't we go ahead and give that a try? So negative 41 is equal to 8 minus 7n plus 7, distributing. Negative 41 is equal to 15 minus 7n. Subtracting 15 from each side, negative 56 is equal to negative 7n. Oh, so we can see that n is equal to 8. So there are 8 terms in this sequence, and you could try starting at 8 and subtracting 7 each time and making sure that by the time you get to negative 41, this is going to be the 8th term. Here's one for you to try. Find a formula for the nth term in this sequence. So all you have to do is find the common difference and then use this formula for the nth term. Go ahead and give that a try. All right, let's check your work. So a sub n is equal to the first term plus n minus 1. All you had to do was find the common difference. So the common difference, if you check out the difference between all those terms, it's equal to -3.